still on your phone? Put them away, please. There we go. All right. So from the title, there's two things that I want to mention. Y'all ready? Underline definite versus indefinite. Definite basically means when there's an integration, it's going to give you a bound. Indefinite means there will not be a bound. It'll just be open-ended. And it sounds pretty obvious. There's a definite number versus not. And then within the sentence, we have something called a particular solution versus general solution. So for the general solution, that means there's a plus C. For particular solution, I'm going to give you a specific value. It's going to be plus some number, a specific number. So the only difference between the particular and general is going to be that the C is replaced with an actual number. Okay? So let's do an example of the particular or general solution for the first one. So I want to rewrite something when we're solving for the differential equation. How else can I write y prime? D what over d what two letters right after d? dy over dx. And I'm going to leave the right side as it is. So our goal is to solve for y. So imagine just thinking about algebra 1. We want to divide or multiply by dx on both sides. So when I do the first, dx cancels out. So I just have dy. So basically, we are distributing. And then on my next part, I know we have two components. I'm going to write out 3x all squared minus 1. And you can write out dx one time. And again, ideally, what should be happening between these two? It should be wrapped up. Because in the end, it's distribution. Okay? But I'm only going to write it one time since I'm going to integrate one time. All right, are we okay with multiplying by dx on both sides? Okay? Now, y is almost by itself. So this is derivative of y. What's the opposite of deriving? Anti-deriving, or it's also called the integrate on both sides. So what's happening here is the integration and our deriving, it's going to cancel out. So we have y now by itself. Now, since today is the first day going over antiderivative, I want to take it step by step. So leave that antiderivative on the right side as it is for now. Just to help us, what can I write with the x for the 1? Power 0, if that helps you. And if you're like, you know what, that doesn't really help me, then you don't need it. So here we go. We have y is equal to, so our rule is, you keep the coefficient, the power becomes 1 more, right? Yep. Right? No, you didn't even write. Over 3 minus 1, x to the 1 over 1. At some point, dividing by that new power should be very natural for you. Since we anti-derived, do I need a dx anymore? We don't? We're going to add what? Add the c. Now let's simplify so we know what our general solution is going to look like. That's going to give us y is equal to x cubed minus x plus c. This right here is our general solution. Because it's got plus c, and we don't know what that value is at the moment, but we will on the next portion. All right, are we good so far? Okay, Xavier, let's read the next sentence or paragraph. Particular
solutions of a differential equation are obtained from initial conditions placed on the unknown function and its derivatives. For instance, suppose you want to find a particular solution whose graph passes through the pattern to equals 4.
So let's actually plug this one in. The 2 is going to be replaced with the, or it's going to go into the x. What letter is 4 going to replace with? By the y? So I'm going to rewrite this guy right here. So y is 4 is equal to, my x is 2, cubed minus 2, plus the c. So now that we have one variable, since x and y are known, we can solve for the c value. So 4 is equal to 8 minus 2 plus c. So how many is my C then? -2. So that means our particular solution is going to be y is equal to x cubed minus x minus 2. So this is our particular solution, meaning we know the value of C. And that was a definition on the top. And if you care to look at the graph on the right, let's go ahead and try it. The graph on the right says, when I have the value of 2 as my y-intercept, right here. Do we all see the y-intercept of -2, I mean? The given graph is actually going through 2, 4. And without the graph, we have enough information, but at least we know. So can we mimic what the equation might be if it's up here or down here? Let's see what would happen right here. What is our y-intercept here? 5. So we have the same equation, except the y-intercept is now 5. Or if I were to go down here, who's my new y-intercept there? -9. So we have the same equation, except the y-intercept is -9. And I know that's extra information, but I want you to realize it's actually just changing the y-intercept. It's kind of like when you have a parabola shifting up and down, and that's it. Okay? So let's go on to the next page. Okay, Milo, let's read number 2.
Find the general solution of dy over dx equals -1 over x squared, and find the particular solution that satisfies the initial condition at 1 or 2.
So we're looking for general solution at the following, and we know we can find particular solution as long as we have our x and y given. So our first part, I'm going to rewrite out the proportion, dy over dx is equal to -1 over x squared. What is our first thing that we must do on both sides? Multiply by what? Dx. So we have dy is equal to -1 over x squared dx. How can I make y by itself? Do what on both sides? What's the opposite of derivative? Integrate or antiderivative. And I know they cancel out. And again, for teaching purpose, I am going to simply rewrite the right side. If you want to derive as you go on, go for it. But if you're like, hey, I need a little more time to process, that's okay. So moving on. Looking at this, we have y is equal to, keep the coefficient, add 1 more to the power, divided by that new power, and we have to do plus what? Plus c. So then our particular solution that I want to simplify is going to give us y is equal to, and it looks like -1 over 1 is simply 1, right? So 1 over x, then I have plus c. Let's box that and write on here, this is our general solution. And our general solution always has plus c. Now for the particular solution, can I plug in my x 1/2 and y 3? Yep. So here's my y, and then 1 over my x is 1 over 2 plus c. When we multiply by the reciprocal, all that fraction is going to give us how many? Oh, 2 plus c. So we know c has to be how many? C must equal 1. So we know our particular solution, meaning the value of c is given or is found, y equals 1 over x plus 1. So let's try example 3 with a neighbor. Find the general and particular solution on example number 3. Go. Talk to your neighbor and rewrite y prime as d over something. Are y'all working together or no? Uh-oh. Did y'all move the dx on both sides? And then integrate? So we got, it's going to give us 6 over 3x cubed minus 1 over 1 x to the 1. And what do we not forget to write at the end? Plus c. And when I simplify further, we get 2x cubed minus the x plus the c. And that is our general solution. And then for the particular solution, all we need to do is plug in. X is our 3. 0 is going to be for the y. So when I do, I get 0 is equal to 2 times the 3 all cubed minus the 3 plus the c. Hopefully we can simplify the simple math. What y'all get as your final c? Negative 51. So our particular solution is going to be y is equal to 2x cubed minus x minus 51. All right. Y'all ready for the last one that's got double prime? Okay. It just means we're dividing by that number one more time or whatever. Okay, we'll see. On number 4, last one. Sophia, let's read. Given.
Given that f double prime of x equals 6x, f prime of 2 equals 13, f prime equals 4. Find the particular solution for f.
Okay, I want you guys to notate this real quick. When I see f single prime, that means when I get to dy over dx, I'm allowed to plug in those two numbers. Okay? And when we get to it, I'll then mention it again. But for now, let's rewrite out the function given initially. So we have double prime is denoted in this manner. If some of you guys are going, why doesn't the y have the squared? That's going back to unit 1 that we talked about already. So I'm just going to move on. So what do I need to do on both sides? How do I make this into not a fraction? Dx squared. So we know we have d squared y is equal to 6x dx squared. And you're like, oh, don't like that. And that's okay. And my goal is to make y by itself. So to make y by itself, I need to take the antiderivative one time for now. So when I do, this antiderivative is going to make the d squared go away and just have 1d. And then I think we can go ahead and derive this, or anti-derive this. That's going to give us 6 over 2x squared. Is everyone good with that? Plus c. Now, when I anti-derived it, does that mean my dx squared both goes away or just one of them? Just one of them. So I'm going to leave that alone, dx. So at this point, I want you to notice something. can I relocate this equation to make it look like dy over dx? I could rewrite this and say dy over dx is equal to, I think I'm going to go ahead and simplify. I guess you don't have to. And what we can actually do is the following. I can plug in the 2 for the x, 13 for the y. And by 13 for the y, I mean for all dy over dx. So we know we have 13 is equal to 3 times 2 squared plus c. And hopefully we can do our mental math here. How many would that give us? If I tell you all that, it's going to give us 12. 1. So we know c is equal to 1. So now let's rewrite what we have. I'm going to rewrite this guy right here. So we have dy is equal to 3x squared plus 1 dx. And I guess the parentheses will be nice, that I might forget from time to time. Is everyone okay with how I rewrote this? Okay? So do I need to antiderive one more time? Yes, I do. Let's integrate. When I do, I get y is equal to, so we have 3x cubed over 3 plus, what would this give us? What is the antiderivative of 1? X. What is the derivative of x? 1. Go back and forth. What do I have to add at the very end? Plus c. Now, be really careful. If I'm anti-deriving twice, should we assume the c is the same on both of them? Let's call this one c sub 2. And if you're like, hey, I don't need the sub 2, I know c is going to be a different number, that's okay. So at this point, let's see what information I have. We have y is our 4, my x is our 1. So my y is 4 is equal to, and when I simplify, I know we're going to get 1 all cubed plus the 1 plus c sub 2. Notice 3 over 3 was simplified, in case you're like, what did you do? So what would our second c be equivalent to then? 2. So our particular solution as our final answer is going to be y is equal to x cubed plus the x, and our c value is plus 2. And